This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. Our second to last proof is this one here, proof 8, where we have to prove that sine of a minus b is equal to sine a cos b minus cos a sine b. And very similar to one of the proofs we did before, we're just going to replace every time we see b with minus b in this formula here that we just proved in number 7. Sine a plus b is equal to sine a cos b plus cos a sine b. So every time we see a b, like here, here, and here, we're going to replace each of those b's with a minus b instead. So we end up with a sine of a minus b on the left, the cos b becomes a cos minus b, the sine b becomes a sine minus b, and then we use those same two rules we used in a previous proof, where cos of a minus b is the same as cos b, and sine of minus b is minus sine b. To rewrite the above line as sine a cos b plus cos a times a minus sine b. And then all we need to do is bring that minus out in front, and we can get our final equation that we are looking for. Sine a minus b is equal to sine a cos b minus cos a sine b. And that is the end of that proof. And finally, our last proof is to prove that tan of a plus b is equal to tan a plus tan b all over 1 minus tan a tan b. Now, to start this proof, we're going to take the definition that we had before of tan, where we had tan of any angle theta is equal to sine of that angle theta over cosine of that angle theta. And then once we do that, in this case we realize that we have an angle of a plus b instead of just an angle theta. So we have sine a plus b divided by cosine a plus b. And then from our previous formulae, we write that sine of a plus b is sine a cos b plus cos a sine b, and cos of a plus b is cos a cos b minus sine a sine b. Now comes the main trick of this question. What we need to realize is that in this part of our equation here, if we look above, it's just a 1. So if we want to have a 1 on the bottom left of this fraction, we need to divide everything in this fraction by cos a cos b, because that's what's written here. And when we do cos a cos b divided by cos a cos b here, we'll get that 1 that we're looking for down below. So then it's just a matter of looking at what happens to all the other parts. So when we divide sine a cos b divided by cos a cos b, the cos b's cancel, and we're just left with a sine a over cos a, which is just equal to tan a by definition. If we divide cos a sine b by cos a cos b, we have our cos a's cancel, and we have a sine b over a cos b, which is just tan b again by definition. Then, if we look at our last part, we have a sine b divided by cos a cos b, which we can write as tan a multiplied by tan b. And if you see here, we just have tan of a plus b which is what we started with, is equal to tan A plus tan B, all divided by 1 minus tan A times tan B, which is exactly what we're looking for up above. And that ends the proof and all of the trigonometry proofs.